Hey everybody, so we're here with the Chapter 2, Part 2 review Edpuzzle. The purpose of which is really just to sort of go through like one problem for each type of problem that you would encounter on the test and that we've gone over in this second half of Chapter 2. And then at the end of the video, I'm just going to ask you kind of um, what concept you want us to go, or what concept you feel you need the most work on. And you can have a couple of answers, right? So during this Edpuzzle, take advantage of the ability to pause, to go back, to try the problems for yourself on scratch paper if you want, whatever you feel would be most helpful to you. Okay? So the first thing we're going to look at is just a translation. And so I'm going to annotate our problem. We have the original function, or the parent function, is f of x equals x to the fifth power. And we're going to write a new function of g of x based on these instructions, essentially. So first thing, we just say g of x equals, and I'm just going to work in terms of each separate part of this new equation, okay? So we have a vertical compression of 2/3. So right away, if I see vertical compression or vertical stretch, that number is just going to go in front of my new equation, okay? Then I've got my x value in our parentheses, right? Because our original equation is x to the fifth. Some of us, I think, tend to get confused here. So I'm just going to close off my parentheses and put my 5 up here now. Let me make that 5 a little clearer. Because again, we're translating the original function, which was x to the fifth. So that to the fifth power needs to remain a part of our new equation. Next, we're translating left 4. So remember, horizontal or left to right translations go inside of our parentheses, and we flip the sign. So it's +4. Remember, if we're moving to the left, we get a plus. If we're moving to the right, we get a minus. And then the last thing I need to do is just this up 2, which goes at the end outside of my parentheticals. And in this case, we keep the sign the same. So it's a +2, right? Because we're moving up 2. We've said this before, but remember, if you're struggling with this concept, kind of the key piece of notation, I guess, or the key note for you is just the annotated equation. Remember, g of x equals a, where a is our vertical stretch or compression, times x minus h, which is our h being our horizontal movement, plus k, which would be our vertical movement. Okay, so if we look back to the answer here, we see this 2/3 comes from the vertical compression. This +4 comes from right up here, where we're translating left 4. And this +2 comes from right here, where we're moving up 2. Okay. So number 2, we're transforming the graph. And our graph right now is the parent function. It's the original function. And we're being asked to transform it based on these changes, right? So again, our original equation is y equals g of x. All right. Now, we have a negative sign right here indicated by this like dot that I'm doing. The negative, when we have a negative inside of the parenthetical there, that's an indication to us that we're reflecting this over the y-axis. So uh, our new graph is going to be reflected over the y-axis. And again, that comes from that negative right there. If the negative were outside, like if our negative was right here, where I just blackened that in, that would tell us that we're reflecting it over the x-axis. And then this +3 just tells us we're moving it up 3. Okay, so I need to both reflect this graph over the y-axis and move it up 3. So I'm just going to draw my line across the y-axis just for reference. And what I'm going to do is just reflect each point, okay? So here's a point. It's at -1, 2, 3, 4, 5, 6, 7, 8, 9. So the original point is -9. I'm reflecting it over the y-axis, so I'm just going to move it to +9. But wait, I'm going to undo that because I also have to move it up 3. So we'll go 1, 2, 3. Okay. Here's my next point, right? This one up there. And that is at the x value is -1, 2, 3, 4, 5. So if I'm reflecting it over the y-axis, I just flip the sign, right? It goes from -5 to +5. So I'm going to count it 1, 2, 3, 4, 5. And remember, we have to move it up 3, so I'm going to go 1, 2, 3. Okay, here's my next point, right? And we see the x value here is +1. So I'm just going to flip that sign and make it -1. And I'm just going to move it up 3. 1, 2, 3. And then here on the x-axis is my last point, which is at +8. So I'm just going to move it to the opposite side on -8. Again, I'm going to undo that because I need to move it up 3. 1, 2, 3. Okay, and then I'm just going to connect my dots. And that's how you would go about transforming that, right? We reflected it over the y-axis by essentially changing the sign on each x value, and then we moved our y values by moving up 3. Okay. So next we're going to graph the absolute value function below based on this equation. Okay. So first things first, remember our original absolute value equation is just f of x equals the absolute value of x. And on our graph, and this is imprecise, but it's our v that goes through the origin that has an up 1 over 1 slope, remember? So when we're graphing that, now, we have to look at sort of our blueprint, like our instruction manual, right? So this -2 indicates to us a vertical stretch, right? Because essentially we're going from, when we talk about a vertical stretch, we're going from like this kind of a V to a more compressed V. And because it's a negative, it tells us that we're actually going to flip our V over so that it's going to be one of these guys, okay? We also have to find our new vertex. And remember, our vertex is just the tip of the V, right? Whether it's upside down or right side up, the vertex is our tip. And the way we're going to find that is just through our 5 and our -1. So remember, our +5 tells us that we just want to flip the sign. So it's a -5. And then our -1, that's our y value, is right there. Okay, so this is our vertex point. Our slope is this -2. Okay, and so we're just going to graph that. So we go -5, -1. So 1, 2, 3, 4, 5, -1. And then I'm just going to count my slope. I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, and I'll do it one more time, down 2 over 1. I'm going to do the same thing on the left side of my upside down V. I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Okay, and then I'm just going to connect. All right, so do we see how that process works? The key is finding our vertex and our slope, right? And we find that information. Again, our slope, to draw my arrow, came from right there. And my vertex, my x value, came from that 5. And my y value came from that -1. Okay, I know that's a lot of arrows going in several different directions, so if you need to pause and rewind and see how I did that, you're obviously welcome to, okay? And again, the reason that it's an upside down V rather than a right side up V comes from that negative sign in front of our 2, okay? Okay, sorry, I had to pause there for a second. Next thing we're doing is graphing linear inequalities, okay? So this is tricky, right? There are a few steps to these problems. First thing we don't is for letter A, we have y is less than -2/3 x, okay? If it helps you in this context to graph it, think of it as y equals -2/3 x. Just be sure that when you go back and plug in, you change your sign. But that, I think when some of us see the less than sign or the less than or equal to sign, it tends to throw us off. But this is the same process that you've used in graphing before. It's just with a different signage. Okay, so our slope, I'm just going to pull from right here, is -2/3, and our y-intercept is just 0. Okay, because y is less than -2/3 x. If you were to make it into slope-intercept form, you would just add the 0. Okay. So with that knowledge, I'm just going to plot my first point right here on our vertex, or at our origin rather, and I'm just going to walk my slope, right? I'm going to go down 2 over 3, down 2 over 3, down 2 over 3, and then I'm going to go up 2 to the left 3, up 2 left 3, and sorry, my eyesight at night, not the best, up 2 left 3, and I'm just going to connect, right? So again, that process of graphing -2/3 x shouldn't really look any different. What I'm going to do next is I'm just going to choose a point on either side of my line, right? So I'm just going to make it easy on myself and choose the point 0, 1. And I'm going to plug 0, 1 into my equation. So it would be 1 is less than or equal to negative 2/3 times 0, which ends up being 1 is less than 0 because any number times 0 is 0. And then I just have to ask myself, is that statement true? Is 1 less than 0? That is a false statement. We know 1 is greater than 0. And again, I want to encourage you to use kind of the smiley face process. So we give them our smiley face, or our frowny face rather, because this is a false statement, which means we're just going to shade in on the other side, okay? Remember to color inside our lines. All right. I'm gonna just color that one more time so we don't lose sight of the actual line. That would be bad. Okay. Let's try another one. So again, same process as if we were graphing a normal line in slope-intercept form. Here's our slope. It is positive 4/3. Here's our y-intercept of negative 2. Okay, so I just plot my y-intercept at negative 2, and then I'm just going to walk my slope up 4/3. So 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. Okay, and then I'm going to walk it downwards. 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. Connect them. And again, I'm just going to pick the easiest point we can, which is going to be, in this case, our origin, 0, 0. So I'm just going to write that down. I'm plugging in 0, 0. So we end up with, and again, there's our x and our y. We end up with 0 is greater than or equal to 4/3 times 0 minus 2. 0 is greater than or equal to 0 minus 2. 0 is greater than or equal to negative 2. That is a true statement. So we get a smiley face, which means we are going to color in this side. Okay. And as I was doing that, I realized I did make one mistake on the previous question. And maybe you caught this and were wondering. Oops, let me change my color. But remember, if we're just talking about less than, we get a dashed line for our graph. Okay. Because here we have less than, or rather greater than or equal to, we have that or equal to, we get the full line, okay? No dashes. All right. So that was essentially one problem from each of our concept lists. From 2.6, we have translations, reflections, and vertical compressions and stretches. We have transformations. 2.7 is our absolute value. And then 2.8 is what we just did with graphing linear inequalities with the dashed or solid line, and then using the test point to determine what we're going to shade. Okay. So I'm gonna stop the video here and you'll have an open-ended question on Edpuzzle. We just want you to list out of the equations that are, or of the concepts that are listed here, what you need the most attention with, and we will tailor our review to that, okay? Um, so again, don't hesitate to pause the video and rewatch certain segments. Um, don't hesitate to reach out to myself or Mr. Schmalzer with questions. Anything is fair game. All right. So best of luck with your studying, and we will see you in class.